Okay, so last slide we were talking about using our slope formula. Slope formula was m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So now this one we're going to kind of shift, and we're going to be talking about rate of change. Okay, so for these here examples, we're going to be talking about rate of change. Rate of change, though, is slope. They are the exact same thing. Okay. Rate of change is primarily used when we are dealing more with real-world situations or when we are dealing with kind of word problem types. Okay, so that's what we're going to go through on this video. So this says college admissions in 2016 were 31,388 first-time college students applied to a state university. Okay, in 2014, 25,949 students applied. It wants you to find the rate of change in the number of first-time college students applying for admissions from 2014 to 2016. Okay, so first off, we need to identify some important numbers here. 2016, there were this many kids that applied, versus in 2014, there were this many kids that applied. Those two pieces of information each go together, and guess what, guys? They make a point. Okay? Now, something that you want to write off to the side here and make a note of, anytime, because right now you guys should be asking, you should be thinking to yourself, okay, yeah, I got a point, but which one's my x and which one is my y value? When you guys are dealing with these problems, time is always your x value. Okay? Anytime you are dealing with time, that is your x value. So our 2 points that we have are 2014, comma, 25,949. That's point 1. And then point 2 is 2016, comma, 31,388. Okay? They're asking you to find the rate of change, which we know the rate of change is just slope. So all you guys need to do to solve these problems is figure out what your points are, and then you're going to use m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay? So, let's just go through and do it. Y equals 31,388 minus 25,949 over 2016 minus 2014. Okay, now we're just going to do a little bit of math. 31,388. Get that in my calculator because I don't want to do that in my head. Mainly because I'm not very good at doing it in my head. Okay, when I subtract those two, that gives me 5,439 over 2. Okay, and when I try to figure out my slope, I always want you guys to leave your slope as a fraction. Slope should always be fractions. However, when you are dealing with a real-world situation, and basically I'm saying when you're dealing with a word problem, it is okay to use decimals, because decimals are typically more applicable in our real-world situations. So, for any of these word problems, you can use a decimal. Any other time, we want to leave them as a fraction. Okay? So I've got 5,439. I'm going to divide that by 2, and I get 2,719.5. Okay? So that is my average rate of change. Now, a couple things that tells us that you guys should, probably jot down. That is a positive number. Okay, so if your slope is positive, remember we talked about positive slope means it's going up, right? So the number of students is increasing in this situation. The number of students is increasing in this situation. Also, it's increasing by 2,719 and a half students per, what's our bottom numbers there? Well, our bottom numbers are years. So that's every year, 2,719 and a half students are showing up for school. Okay? That's kind of what that rate of change is telling us. Remember, rate of change is just slope. Okay, we've got another one. This time it's in a table. Okay, again, how do I tell what's my x and what's my y? Remember, our golden rule, write it down if you haven't already. Our golden rule is time is always your x value, which means that in this case, distance is going to be our y. Time is always going to be your x. Okay? So I've got all these values here, and guess what? These are all points. Every single one of these are points. How many points do I need to have to try and figure out what the rate of change is? Well, remember, your rate of change is just your slope. So as long as I have 2 points, I can tell us what the slope is. I'm going to pick this point and this point. Why? Because those are the 2 smallest numbers. You can use any of these points, though, and that will still give you the correct answer. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, I'm just going to simplify. 16 minus 8 gives me 8. Over 4 minus 2 gives me 2. That tells me that my slope is 4. Okay, so we are comparing time and distance. Okay, so basically what that's telling us, first off, it's positive, so our distances are increasing, right? Second thing it tells us is that our distance is going up by 4 every minute, because we're talking about minute. Distances are going up by 4 every minute. 2 to 3 up by 4 would be 12. 1 minute increasing by 4. Okay, it follows that pattern. You guys might look at that table and be like, no, that's increasing by 8. Well, it's increasing by 8 because your numbers are jumping up by 2. Okay, right here it jumps up by 4, so it's increasing by even more. Okay, but that slope that's a constant value, and that information up there in the table, everything is increasing by 4 every minute. Okay, got a couple more examples. The other example we have right now would be average rate of change. And an average rate of change is going to be something that you would use for something that's nonlinear. So if you guys look, it might be kind of hard to see with this graph, but this isn't linear. It's kind of curving upwards. Okay, but they can use your slope formula. You can use your m equals y sub 2 minus y sub 1 and x sub 2 minus x sub 1, and that will give you the average rate of change. So it's kind of averaging everything out for that. If they give you the average rate of change, they're going to give you the 2 points. Like, hey, we want to know the average rate of change from 2001 to 2006. So you are specifically going to be looking at 2006, and there was 34 thousands. Okay, so not just 34 thousands, versus 2001 when there was 7 thousands. Okay, so I'll go through, plug in my points. We'll do this one 0.2, this one 0.1. So I'm going to do 34 minus 7 over 2006 minus 2001. Okay, so 34 minus 7 is going to give me 27 over 2006 minus 2001. That's going to give me 5. Okay, again, remember, totally okay with you guys using decimals when we are dealing with word problems. 27 divided by 5, it's going to give me 5.4. Okay, now remember, 5.4, that is 5.4 thousands. Okay, so almost 5,500 per year is how much that is growing. Is this number exact? This number is not exact for this situation because this is a nonlinear example. This is just our average rate of change. Okay, you guys could also see these. This might look kind of like a scatter plot. Okay, again, they're not making a line. Okay, you could use that as well for these situations here. This one, I'm looking at my average rate of change. Remember, it's average because this is nonlinear. Average rate of change for 2000, it was 61%, versus 2004, it was 74%. I would just use my slope formula to figure that out. Pause the video, see if you guys can give me the average rate of change. Okay, I'm going to go 74 minus 61 over 2004 minus 2000. Okay, again, remember I know that my 2004, my 2000 are my x's because time is always our x value. Time is always our x value. So this would be 13 over 4. 13 divided by 4 would be 3.25. I think. Yeah, because 12 divided by 4. Yep, okay. 3.25. Now, this case here, that's 3.25 over a year. That is 3.25%. So there's a 3.25% increase over every year. We didn't have any cases of this, but what if this would have been a negative value? Okay, if that was a negative 3.25, then that would have been a case of 3.25% decrease over those years. Okay, all of our slopes on these just happen to be positive, so those are all increases. If it was negative, it would have been a decrease.